Question number 31. Integral 0 to pi by 2 sine 2x into tan inverse of sine x. So first we reduce into the same angles. So I'll use the formula for sine 2x. Integral 0 to pi by 2. This is 2 sine x cos x into tan inverse of sine x. Now here it's quite obvious that if I put sine x equals to t, this becomes tan inverse t, and this much becomes dt. So I'll take substitution. Put sine x equals to t. This is a substitution. If I take sine x equals to t, you need to differentiate. Cos x equals to dt by dx. Dx this side. Now in definite integral, usually we change the limits when we take the substitution. Without that, even it can be done. So here lower limit is 0, that is for variable x. So if x is 0, put here sine 0, 0, that is t. So now lower limit is 0. If x is pi by 2, it implies put here. So sine pi by 2, you know it is 1. So t becomes 1 now. So limits are 0 to 1 here. Earlier 0 to pi by 2. So 0 to 1, new limits. 0 to 1. This much becomes dt, as I told you. This is dt. This is t, this is also t. So it will be t tan inverse t and 2 outside because it's a constant. Now we use integration by parts. So you recall the Liet rule. Inverse and algebraic. So inverse occurs first. This is u, this is v here. So this is u, this is v here. So I'll do by parts. Integration by parts. We know it. So over here 2 is already there outside. U will come outside, so tan inverse t will come outside. Integral of t, that's t square by 2. And what are the limits here? 0 to 1. Minus inside the integral, differentiation of tan inverse t, which is 1 upon 1 plus t square, into the same thing which you wrote here, t square by 2. One more dt, you know. That we know here. This 2 is for all, remember, so I'll keep 2 outside. Now here upper limit, so if I put 1 here, tan inverse 1 pi by 4, this is here 1, so pi by 4 into 1 by 2 minus tan inverse 0, 0, so this is 0. What about this? Here 1 by 2 outside as it is. T square upon 1 plus t square dt. This is quadratic upon quadratic. So we set the 1 plus t square here. So I'll write plus 1 minus 1 here and then split into 2 integrals. I'll take 2 inside now. So 2 will get cancelled. This is just pi by 4. Minus this 2 will get cancelled. Integral 0 to 1. Do individual division. This upon this is just 1 and this is 1 upon 1 plus t square dt. Now integrate it. Both can be integrated. It can be done very easily here. This is t minus, you know, this is tan inverse t. And limits are from where to where? 0 to 1. So here pi by 4 minus, put 1 here. So 1 minus tan inverse 1, which is pi by 4. Lower limit, both are 0 here, remember. 0, 0, so this is just 0. So this will be pi by 4 plus pi by 2. It would be just pi by 2. Minus minus plus minus 1. This is the final integral, pi by 2 minus 1. The left hand side was just I, look at there. So I equals to pi by 2 minus 1. That's required integral. Next question, 32. I equals to there integral 0 to pi x tan x upon sec x plus tan x. Now we'll just convert into sine cosine first. Everywhere I'll write in form of sine and cos. So this will be sine by cos, 1 by cos, sine by cos. So 0 to pi x sine x upon cosine x upon 1 by cosine x plus sine by cos. So cos will get cancelled after taking LCM. So we are just getting 0 to pi x sine x upon this cosine and this cosine will get cancelled. 1 plus sine x. We are getting this. Now can see nothing can be done and this is a definite integral. So what we do, we use that property, replace, this very standard property, replace x by pi minus x. So therefore I equals to integral 0 to pi, here x is pi minus x into sine x upon, why sine x? Because sine pi minus x, second quadrant, sine is positive, so it is just sine x. We have used indirectly this concept, remember. 1 plus sine pi minus x, which is sine x. Now I'll split into two integrals, 0 to pi sine x upon 1 plus sine x minus integral 0 to pi, this is x sine x upon 1 plus sine x dx. Now the second integral is just I, you see this is same as the question, you can call this as 1 here. So this becomes just I, this much is I. I'll take I on the other side, so this become 2I. This minus I on the other side, pi being constant I'll keep outside. 0 to pi sine x upon 1 plus sine x. Fine. Now the question is how we'll integrate this. That's important question here. You just need to recall earlier we had mentioned points to remember for integration. If you have 1 plus or minus cos or 1 plus or minus sine, we can take conjugate here. I want just I here only, so I'll write here pi by 2, taking 2 on that side. 0 to pi, here sine x into 1 minus sine x upon, what will get? 1 plus sine into 1 minus sine, so it would be just cos square x. I have dropped one step, remember here this expression is multiplied with 1 minus sine x. So this is a square minus b square. So this would be pi by 2 here, integral 0 to pi, this upon this, if I open the bracket, sine x upon cos square, which is tan x into 1 upon cos, which is sec x, minus, if I open the bracket, this is sine square upon cos square, which is tan square. Now both have standard functions, we can integrate it very easily, remember. How will integrate? Tan square cannot be integrated directly. Instead of tan square, what you are going to write? Sec square x minus 1. I'll place this instead of tan square. This is a very well known standard function. So let me do this integration here. If I continue here, the integration, you have your pi by 2 equals to, this is just sec x minus, this is tan x and this is plus x, and limits from 0 to pi. What's integral of tan x into sec x? It's just sec x. What's integral of sec square? Tan x, and minus minus gives us plus here. So pi by 2 as it is. First upper limit sec pi you know minus 1, 10 pi 0, this is plus pi. Now lower limit, sec 0 1, 10 0 0, this is 0. So this is equals to here pi by 2. This is pi minus 1 minus 2, so pi minus 2. That is final integral. Next question 33, it's about modulus here. So I'll split into three integrals, 1 to 4 modulus x minus 1 dx plus integral 1 to 4 modulus x minus 2 dx plus integral 1 to 4 modulus x minus 3 dx. Now we know how to solve such moduli questions. What we do? We find x for which this becomes 0. Where this becomes 0? At 1. Now 1 is already one of the boundary. So here directly I can write here integral 0 to 1 to 4. Pick up any number from 1 to 4. Suppose I have taken 2, place here. It would be positive, so it is just replaced by itself. From 1 to 4, this is always positive. Take any number from 1 to 4. You will notice that this is always positive. Now what about this? Where this becomes 0? At 2. So we need to split into two limits here. 1 to 2 and then 2 to 4. This is from this, remember. dx. Here you have dx. Now if you take any number from 1 to 2, for example 1.5, then this is negative. So you have minus sign in front of this. And from 2 to 4, this is always positive. So this is just plus sign. Okay. These two integrals are reduced from this only, remember. Plus, now next third integral. Where this becomes 0? At 3. So integral 1 to 3 here plus 3 to 4. This is from last one. Now if you take any number from 1 to 3, this is negative. So you have minus sign in front of this. And from 3 to 4 you pick up any number. This would be always positive. So this is plus. I hope you know this. Now very simple. I'll not do. Just integrate. Right, upper minus lower, integrate it. All are very simple functions. Remember you have 1, 2, 3, 4 and 5. This many functions are there, remember. Not a big task. You know, like if I do first one here, x square by 2 minus x. Limits are from where to where? 1 to 4. Simplify. And so on. Next, go for this. Next, go for this. Then this one and simplify. So we'll get the backside answer. The only important thing is how to remove the modulus. I repeat one more time. How do we remove the modulus? Find x for which this becomes 0. Where this becomes 0? At 1. So x equals to 1 here. But here lower limit is already 1. So you cannot split further. That means now either this should be always positive or negative. So how do we check this? Take any number from 1 to 4. Suppose I have taken 2. Place here, it will be positive. So we just replace by itself. And here or here, this becomes 0 at 2. So we split at 2. 1 to 2, 2 to 4. Remember. Then here 1 to 3, 3 to 4. Fine. Next question 34. You are given this integral 1 to 3 and you want to prove something. Okay, so now by observing the question you might have realized product of linear factors with repeated expression. So standard way of doing this is partial fraction method. So how we'll do this? Like you have here function as this. So I write a upon x plus b upon x square plus c upon x plus 1. Now what we'll do? We just take LCM here on the right hand side. LCM should be this, remember. Numerator is 1. Now here a into x is there. LCM should be x square into x plus 1. So x into x plus 1 plus b into here This x square is already there, so you have just x plus 1 plus c into you have x square, and now you just compare different values of x and you get a, b, c and place there. That's one way. This is very standard way of doing. Alternatively, without doing all these things, you can do like this. Here I equals to integral 1 to 3 x square into 1 plus x dx. So here we always try to set this denominator expression in the numerator. So I'll write plus x minus x upon x square into 1 plus x, adding and subtracting x. Now do individual division. Integral 1 to 3, this upon this is just by x square, minus what about the other integral, this upon this, so you are left with just x into 1 plus x. Okay, I repeat this. What I did, individual division, these upon this, so you are just left with by x square, this upon this, so 1x will get cancelled, so you are having this. Now one more step, here this is the product of two linear factors, which you can express always as a sum or the difference of two factors. Now here factors are so simple, so just you can put minus sign between these two. This is indirectly partial fraction method, remember. That is same as you write plus x minus x, you will get exactly this. You just do the cross multiplication, you will get exactly this. So all are now standard forms. So integrate this. What's the integral of 1 by x square? You know, minus 1 by x. Limits are from where to where? 1 to 3. Minus, what's the integral of this? It is log of mod of x. Minus, what's the integral of this? Again, linear function, log of mod of 1 plus x. And limits are from where to where? 1 to 3. Fine. Now just upper minus lower. We'll do just upper minus lower. So here minus sign as it is. First put upper limit. So 1 by 3 minus 1. Minus you keep outside, 1 by 3 minus 1. Minus, let's put upper limit first. So this is log 3 minus log 4. Now lower limit. What's the lower limit? Log 1, which is 0, minus you put here 1, so log 2. So let's simplify further. So if I simplify here, the first expression is just 2 by 3 minus, what about this? This is log of 3 by 4, you know that subtraction become division, plus log 2, and this is equals to 2 by 3, that addition becomes into here, so 3 by 4 into 2, addition become multiplication, so here 2 by 3 minus log of 3 by 2, that is the RHS, and hence proved. Remember, there on the right hand side your plus, but which is same, remember this 2 by 3 as it, you take the reciprocal here, so it would be like this, 2 by 3 raised to minus 1, and this minus 1 will come in the product, so your plus 2 by 3, whether you write this or this, both are same. Okay. The next question, it's very simple, 35. You do just by parts. I equals to, you have integral 0 to 1 x into raised to x dx. So this is combination of which two functions? Exponential and algebraic. Exponential is last, before that you have algebraic. So this is u, this is v. So by parts here, that u will come out, x will come out, integral of e raised to x, limits are from where to where? 0 to 1, minus, inside the integral, derivative of x with respect to x1, integral of e raised to x, and then whole integral. So one more step before I put the limits. This one right now as it is. Here e raised to x, and then again integration and then limits. So 0 to 1. Now put upper limit 1 into e raised to 1 minus 0. Here e raised to 1 minus e raised to 0, which is 1. So e will get cancelled, so we'll get 1. This is what integration by parts. Next question. Minus 1 to 1 x raised to 17 into cosine raised to 4. You have opposite limits, so you can think about even or odd function. So here function is x raised to 17 into cosine raised to 4. You know that this is always even and this is odd, so it has to be an odd function. So if I replace x by minus x, you will notice that the minus sign will come out. This is even function, so this remains same. X raised to 17 into cos raised to 4. So this is minus fx. So what's the conclusion? F is an odd function. And if the function is odd, the value of the integral, if you have opposite limits, is always 0. So therefore I is 0. Your opposite limits, that's why remember. What about question number 37? It's just based on indefinite integral 0 to pi by 2 sine cube x dx. How do we integrate sine cube? You know it. Just use formula of sine 3x. What's the formula of sine 3x? 3 sine x minus 4 sine cube. Get sine cube from this, place there. We did number of questions in indefinite integral. So 0 to pi by 2, we are making this as a subject of the expression. So 3 sine x minus sine 3x by 4. This 4 will go down dx. Now all are standard functions, so this can be integrated very easily. Here 3 as it is. What's the integral of sine? Minus cosine. This is linear function with coefficient of x equals to 3, remember. So plus, what is this? Cos 3x by 3. And limits are from where to where? 0 to pi by 2. Integral of sine is minus cos. This is nothing but the cosine 3x by 3. 1 by 4. Now put upper limit. Cos pi by 2 0, cos 3 pi by 2 is also 0, so 0 plus 0, minus, put 0 here, minus 3, put 0 here, so 1 by 3. So what we'll get from this, if you just simplify, 1 by 4 already you have. This is nothing but minus 8 by 3, so it becomes plus 8 by 3. And therefore, the integral is 2 by 3. This is the required integral. Next question, 38. 0 to pi by 4. You have 2 10 cube. These also you know how to integrate. I'll keep 2 outside. 0 to pi by 4 as it is. This will write 10x into 10 square. This is way of standard way of doing this. You reduce into the smaller power. Now what we do usually, instead of 10 square, we write sec square minus 1. So here I'll write sec square x minus 1. You know 1 plus 10 square is sec square. Now split into 2 integrals. So integral 0 to pi by 4, 10x into sec square dx minus 0 to pi by 4. Remember 2 is common for both, so here also I'll write 2 minus 10x here. Okay, now how we'll do this? You just recall, you take this as a t for example. So this become dt. So this is t dt. So t square by 2, that is 10 square x by 2. Limits 0 to pi by 4. Even you can do directly also. You take this as f, then this become f dash. So if you remember, raise the power by 1 here. Power is 1, so it becomes 2. That's another way of doing this. 2 into, this is log of mod of sec x. You know, this is very standard formula. Limits are from 0 to pi by 4. 2 will get cancelled. Here 10 pi by 4 is 1, 10 0 is 0. Minus 2 into, this is log of sec pi by 4. It's root 2 here. Minus, put 0 here. Sec 0, which is 1, and log 1 is 0. So we are getting here 1 minus 2 into, this is log of, root means raised to 1 by 2. And this 1 by 2 will come in product. So 1 minus 2 into 1 by 2 into log 2. So you have 1 minus log 2. That's your RHS. Integral 0 to 1 sine inverse dx, remember. Now when you have single function, we always use integration by parts by writing into 1. So first I'll do as an indefinite. Sine inverse x into 1 dx. Now single function is always u, this is v. So if I use integration by parts, sine inverse x will come out. Integral of 1 is x minus, inside the integral, derivative of sine inverse x, it is root of 1 minus x square. Here integral of 1 as I have written here, x dx. Now second integral, which is linear upon quadratic. So I can set the derivative of this quadratic. What is that? Minus 2x. So that can be set very easily. I'll take minus inside and multiply and dividing by 2. So minus 2x upon root of 1 minus x square dx. So sine inverse x into x plus 1 by 2. Now here I can write like this, 1 minus x square raised to minus 1 by 2 into minus 2x dx. Now this is f and this is f dash. This much only f, remember. So raise the power by 1 here. So 1 by 2 as it is. You raise the power by 1. 1 minus x square, 1 by 2 upon 1 by 2 plus c. Which formula I've used? This integral of f raised to n into f dash equals to n plus 1 upon n plus 1. Fine. That's what I've used. So this will get cancelled. So this is indefinite integral. Root of 1 minus x square plus c. And therefore I equals to, I means now definite integral. So apply the limits here. Sine inverse x into x plus root of 1 minus x square plus c. Limits are from 0 to 1. First put upper limit. 1 sine inverse 1 pi by 2. This is 1. Put 1 here. This is 0. Minus sine inverse 0, 0, 0. Here this is just root 1 minus 0. And that c will get cancelled, so that's not important. So you are getting finally pi by 2 minus 1. That's required integral, right? See, what I did here in integration by parts, first I did by indefinite integral, and then place the limits. Now if you remember question number 35, there what I did directly. There I did directly. So in the first part I placed the limit, In inner integral here you might have noticed we are not putting the limits, remember. That might be a little confusing for you. Only in outer integral we are putting the limits, remember. That question might be there in your mind. So if you feel that here there is a confusion, you can do as an indefinite integral, as I did here, like this, as an indefinite integral, and in the final step you can put the limit like this. The choice is yours, whichever you want to do. You just see the question number 35, how I did the integration by parts. Here I did as the indefinite integral first and then I placed the limits, remember. Question number 40, we want to do by limit of a sum. So here let's recall fx is a raised to 2 minus 3x on domain 0 to 1. So therefore h equals to b minus a 1 minus 0 by n. So it implies h equals to 1 upon n, where n belongs to n. So nh is 1, that we use later on. We call this as 1. Okay, now by definition here, I equals to, I means given integral. Here you have exponential function. So I'll write limit h tends to 0, h into sigma I runs from 1 to n f of a plus ih. You know this. But what is a here? That is 0. So h as it is, sigma I runs from 1 to n. This is 0. So you have f of ih only. And what is f of ih? You know it is e raised to 2 minus 3ih. So you have e raised to 2 minus 3ih. What's the formula for function? Just go back to formula, you will realize. Here, what is fx? E raised to 2 minus 3x. But here that inner expression is ih, so e raised to 2 minus 3ih. Now, we split this, I runs from 1 to n. This is e raised to 2 into e raised to minus 3ih. This is a property of exponent, e raised to x plus y, e raised to x into e raised to y here. Right? That you have used. Okay. Now this is constant, so I'll keep it outside the limit, e square, remember. Limit here, h tends to 0, h as it is. Now you have this much only. So I'll drop the sigma notation. In exponential questions, if you recall, we used to do like this. First put I equals to 1, so e raised to minus 3h. I equals to 2, e raised to minus 6h. Then minus 9h and so on. And the last term is here, e raised to here n, so minus 3nh. Okay. Now we know this is a geometric progression where a is first term, that is e raised to minus 3h, r that is a common ratio, these upon this, which is e raised to again minus 3h. First term, these upon this, that's this. So we use that summation formula, e squared as it is, limit h tends to 0, h as it is. What about this a? What is a? E raised to minus 3h into r raised to n. E raised to minus 3h, the whole raised to n, minus 1 upon e raised to minus 3h minus 1. Which formula have used? A into, r raised to n minus 1 upon r minus 1. This is the formula for Sn here. Okay. Now, if you remember here, what we do, we take this h with this. So let me just set this here. So over here, So next step is here e square as it is, limit h tends to 0, h upon e raised to 3h minus 1, e raised to minus 3h as it is. This power of the power gets multiplied, so we'll get the nh. What's nh1? So it is just e raised to minus 3 minus 1. Which concept you have used? nh equals to 1. We already used such things twice. See, this one is here set with the limit formula. This one as it is, this power of the power get multiplied, which is nh is 1. So you have just e raised to minus 3, minus 1 is already there. Now here, if you recall that exercise, if you have minus 3, here also required minus 3. So multiplying with minus 3, your e raised to minus 3h as it is by minus 3. Right now this e raised to minus 3 minus 1 as it is. Which formula I'm trying to use? This one. Limit h tends to 0, e raised to h minus 1 upon h is always 1. So this and this should be same, remember. Here you had only h, you have minus 3, so multiplying and dividing by minus 3. Now everything is set here. This is 1. You know it, we did it twice earlier. So this is 1. H tends to 0 here, so e raised to 0 by minus 3. And this is e raised to 3 minus 1. Okay. So finally what we are getting here, e squared by minus 3. Here I'll write 1 by e cube minus 1, and let me just simplify. So 1 minus e cube upon minus 3 e cube. I'll use minus with this, so 1 by 3, 1 e will get cancelled with this, and here you have e cube minus 1. That's final integral. Question number 41. Integral of 1 upon e raised to x plus e raised to minus x dx. I'll write as 1 upon e raised to x here. So this is equals to, if I continue from here, e raised to x upon e raised to x whole square plus 1, taking LCM here. What I did? Just taking LCM, and this denominator of the denominator becomes numerator. Now take this as a t. Put e raised to x equals to t. So e raised to x dx equals to dt. So this will be dt here into t square plus 1. So this is just tan inverse t. But what was t? T is nothing but here e raised to x plus c. So tan inverse of e raised to x plus c, that is option A here. So here your cos 2x, here sin x plus cos x. So we use the formula of cos 2x in terms of cos and sin, which is cos square x minus sin square x upon sin x plus cos x the whole square. Now these are two factors, cos minus sin and cos plus sin. Upon sin x plus cos x the whole square. One factor will get cancelled. Your cos x minus sin x upon sin x plus cos x. Now you can see that this is probably in the form of f dash upon f. What's the derivative of sine? You know cos. And what's the derivative of cos minus sine? So this is f, this is f dash. So what's the integral? Log of mode of denominator function. Sin x plus cos x plus c, which is nothing but b. The next question here, question number 43. You are given f of a plus b minus x equals to fx. That's given to you. Your y equals to integral a to b x into fx dx. Now here simply use this concept. X is replaced by a plus b minus x. Replace x by a plus b minus x. I'll use that. So therefore again I equals to integral a to b. X is a plus b minus x into here f of a plus b minus x. But you know in turn this is same as fx. So integral a to b a plus b minus x into fx dx. Okay, now we split into two integral a plus b into fx and x fx. If I do that here, I equals to a plus b will come out, integral a to b fx minus x fx, a to b x into fx dx. You know that this is nothing but the given integral I. You take on the left hand side, so it becomes 2i. So 2i equals to a plus b into integral a to b fx dx. And therefore I equals to a plus b by 2 integral a to b fx dx. This is the required integral, and which is nothing but your choice D, I suppose. So next 44 number, integral of 0 to 1 tan inverse 2x minus 1 upon this expression. Here we set like this. This is an important example. Tan inverse, I'll write this like x plus x, and I'll take minus 1 with this. So your x minus 1 plus x upon 1. I'm taking minus x common from this. So here your x minus 1. So you must have realized what I did here. This looks like x plus y upon 1 minus x into y. If you just recall this formula, tan inverse x plus y upon 1 minus xy. What is that? You know, tan inverse x plus tan inverse y, if the product of xy is less than 1, that you know. So here both are from 0 to 1, so obviously product is less than 1. So here if I use this concept, tan inverse x minus 1 plus tan inverse x, integral from 0 to 1. Now let's split into two integrals, 0 to 1 tan inverse x minus 1 plus integral 0 to 1 tan inverse x dx. Now this you can do by parts very easily, but before we do that, here you can take x minus 1 st, or you can replace x by 1 minus x, a minus x. I'm using this property only in the first integral. So what happens? 0 to 1 tan inverse 1 minus x minus 1 the whole dx. integral 0 to 1 tan inverse x dx. 1 will get cancelled. This minus sign you are getting, integral 0 to 1 tan inverse of minus x, so minus will come out, tan inverse x, integral 0 to 1 tan inverse x dx. So both will get cancelled. Answer is 0, which is nothing but option D here. Here what I did, this is tan inverse of minus x, so that from tan inverse that minus will come out. You have used this property, tan inverse of minus x equals to minus tan inverse x. You know this, that minus sign will come out here, that I've used here over here, so that's why you are getting minus. Therefore you have this.